Hello, everyone. Good to see you for the tutorial on studying antisocial behavior in social media. I'm Anatoly Krust, co-director of the Social Media Lab. And today this tutorial is presented with also Alyssa Saifu, who is here with me today. Hi, Alyssa. Both of us here in Toronto Metropolitan University, but we're socially distancing in different rooms. So we don't have to wear a mask in front of you. I will start the tutorial with general introduction into the topic. We'll talk about the state of the social media research in this area. And then Alyssa will dive deeper into more hands-on parts. And you're welcome to actually follow us during the second part of the tutorial. We'll tell you how. Essentially to analyze a data set coming from social media, to identify toxicity, and then visualize it using a network analysis, and specifically a form of this network analysis called signed networks. We'll tell you all about it, but for now, welcome. We're really excited you are here. I just do a quick audio check and slide check. Can you see and hear me? Alyssa, thumbs up. How about everybody else? Can you use the Zoom feature? Thumbs up. To show you here. Awesome. Yep. Sounds great. Well, let's get to it. We are broadcasting from the Social Media Lab. We are multidisciplinary research laboratory here at the TED Rogers School of Management. And we study how social media changes the way we communicate, collaborate, and connect with one another. So, and a big part of this social media research is actually anti-social media behavior that we've been observing on various social media websites. We're trying to understand the source of what we describe as antisocial behavior, and we'll get kind of deeper into definitions soon. We're trying to understand how it propagates and how to create healthy online environments for various online communities that are using social media. Some of the posts included in this presentation, I just want to warn you, will have some offensive language. Just kind of comes with the territory of studying this stuff. So the post like this one, she's a shitty person. You are effing idiot. Keep that in your country. Or bet you would F a billionaire. And who are you? Question mark. Last I checked, I don't answer to you, so F off. So unfortunately, and very sadly, more and more of us seeing more and more of this type of posts. And in some cases, it's actually such post would be at us. And so we're trying to, well, understand the prevalence of such toxic interactions and then impact of such interactions on individuals, individual social media users, as well as on online groups overall. But first and foremost, we'll have to detect instances of such a behavior. And this is the tutorial is about that, exactly that. How do we detect instances of toxic interactions and how do we analyze? But first, let's talk about general trends and research in this space. We know from a number of surveys, and this is on this slide, I'm showing you a Pew Research Center survey among US adults found that 41% of Americans have personally experienced some form of online harassment, and they compare their data to 2017 and 14 years, and there are some charts showing different types of threats and online harassments are on the rise in the US. But we also look at some other surveys around the world. This one is from World Wide Web Foundation, found that about half of young adults have experienced online abuse, and majority of them, 68%, reported experiencing it specifically on social media. So to respond to this growing crisis, online platforms, social media platforms in particular, are starting developing. Some of them developed, some of them in the process of developing various community standards and anti-bullying, anti-harassment policies. Here, we just showing you an example of policy from Twitter. Essentially, it has a list of topics and kind of characteristics that identify whether a tweet is, they have to act on it or not. So it could be promoting terrorism, if there's a clear and direct threat of violence against an individual, if a post essentially sharing some private information, such as home address or non-public personal phone number, posting intimate photos or videos of someone without their consent, engaging in behaviors leading to child sexual exploitation, encouraging or promoting self-harm. And some of these lists are evolving, but of course, devil's in details. How do you actually operationalize many of these terms? But for now, let's put that aside, and we'll examine next if there is a policy and platforms promise to act on anything that fits under the anti-harassment, anti-hate speech policies. What do they actually do? And so in the lab, we did this experiment, this review, looking at the stated terms of service and policies across different platforms, and we found that majority of them, this set of bubbles here on the top right side, they said they would remove content. That's the most popular action, declared action anyway, platforms will take. The second most popular action was restrict an account. Disable an account was explicitly stated by only Facebook, Twitter, and Twitch. Deleting an account, a few more platforms join on that action. Removing from the search, interestingly, only stated that they're doing it TikTok and Twitter. And there are other options like remove from recommendations, add cover to shocking content, reduce distribution, remove monetization, not notify law enforcement. And these are just based on the stated policies. In reality, some of them actually do different things, but because the policies changes, they don't change as fast as the action by the platforms, they can be disconnect slightly, and that's also a part of this problem. This disconnect between stated policy and objectives and how they act on certain content and what the platforms actually do is a problem here as well. To understand kind of the prevalence of this type of toxic content or harassment content, bullying content, we can turn to some of the transparency reports that platforms like Facebook started putting out because of the public pressure and other drivers. So what we're looking at right now is the chart showing when or how many times Facebook took action on the content they label as bullying and harassment. So, and you can see they start tracking that in 2019, and the amount of content, this is number of posts in million, were around 2 million in 2019. Then something happened in 2020. So it jumped exponentially. Perhaps yes, election happened. So it could be, it's hard to read these charts because we don't know if it's because they changed something in the system to detect this type of content, and that's why they're taking more action, or is it truly the prevalence of such content went up? So it's a bit of both and a bit of guessing game sometime. But you can see that in 2019 and early 2020, there's consistency slightly over 8 million, 9 million and a half. The first quarter of this year of action taken by platforms specifically for bullying and harassment content. Facebook also identifies specifically hate speech related content, and they provide different charts for that content. And you can see similar trend lines. They identify more hate speech content, about twice as many messages identify that. It peaked again in 2019. And then it kind of drops off. So first quarter of this year was about 15 million messages. And so when you read the kind of explanation to this chart, they say, well, because here they represent number of unique posts. And sometimes if you have coordinated behavior or you have one spammer posting millions of hate speech messages and they remove those millions or thousands, so it could kind of amplify the charts, even though those messages might have not actually reached individuals. So that's why it's only one side of the story, only one dimension. So to summarize, essentially, yes, we do see the kind of spike, at least based on the self-reported survey data that social media internet users are reporting, being, experiencing, they're observing this type of online harassment of different forms and shapes. We also see platforms under various pressures from the society, government, threats of being regulated, enacting different community standards and norms with no consistent process in place, and the platforms have different policies applying to different messages. Enforcement action are inconsistent as well and opaque. And in the review process, what we see in social media users themselves say that it's taking too long, and that, of course, can discourage them from reporting next time. And platforms, while they're trying to say they trying to catch coordinated harassment campaigns, they're still not good at it. As an example, we can turn to yet another chart provided by Facebook to us, and this is specifically showing the percentage of violating content that they classify as bullying and harassment that was eventually removed. And then they do the breakdown. What's the percentage was removed because users reported it versus because their platform automatically detected it? And so this chart suggests that in mid-2020, it looks like they did something to the automated system that it started blocking more of this type of messages, bullying and harassment. Potential improvement, we don't know again. But what we still can see, even though this darker blue, the percentage of content they flagged it, and it could be just their moderators too. It doesn't necessarily mean everything was more automated. But yet 33%, Facebook still relies on users to report for 33% of these messages. So even the state of the art of detection, this type of content is not catching nearly as doesn't catch most of them. So we still have to rely on individual users, and it comes with that approach of relying on individual users to protect themselves. It's always very problematic. So for today, this is just to set kind of the stage for discussion and to kind of spike our interest in this area. Let's look at the state of research. How do you detect? So today we're only focusing on the detection part, especially from the researcher's side, whether you want to study detect antisocial behavior, toxic interactions for the purposes of investigating linguistic features of the content or exploring the actors behind it, or whether you want to study it with implications to recommend policy change or interface improvements for the platforms. The objectives might be different. So the piece of the detection part probably will be the same. So from the state of research on antisocial behavior, we can turn to Web of Science. And so Web of Science, of course, indexes majority of published peer-reviewed academic articles, both published in journals and proceedings. And when we searched for articles, we had a variety of different keywords that would represent antisocial behavior, trolling, doxing, and various versions of this behavior. And so we found about 1,100 actually articles in this data set. And then we use a program called Behaviour. It's a free software, very helpful in analyzing publications, abstracts, and building this type of semantic network. So what you see here, the keywords or bubbles that represent keywords from abstracts of this 1,100 papers published in this body of knowledge. And the larger bubble, it means more frequently the term is used. And then this software, Behaviour, is very handy. It helps us to identify clusters of related keywords. Essentially, when keyword A co-occur with keyword B in the abstract more than once, it can group them together. So what this allows us to identify areas of literature in this space that kind of related in some way. It could be a sub-area, subtopic, could be methodologically similar. So what we zoom in today on these three larger clusters, the red cluster on the left, And then on the right side, you have very interconnected clusters, the blue cluster and green one. Let's talk about the red one. So when we actually examine, we try to kind of deconstruct. Sometimes it's unclear by only looking at the keywords like participant and the mediation model, age. Sometimes it's not clear what kind of methods or questions those papers address, but by examining some sample abstracts, it became clear that this red cluster is mostly based on self-reported data, so surveys of some cases patients, but in others it's just online participants, young adults or other groups that were surveys about their online experiences, and specifically in relation to antisocial behavior online. And so the Pew internet center surveys that I mentioned earlier would be one example of this type of study, where they, for example, identify that 27% of US adults who have experienced, they experience offensive name calling. That's the most kind of common online harassment activity, apparently. The second most common was personal embarrassment, followed by physical threats, and so on. So that's kind of self-reported data. It's important data. It's important snapshots to understand a particular population and their experiences online. But of course, it doesn't tell the full story. So we really want to also look at the observed data, what actually happening, and that's this tutorial is all about, to analyze, observe the data from social media. And this brings us to the other two large clusters that I mentioned earlier, the green color cluster number 2 and the blue color cluster number 3. So they're actually interconnected. They're somewhat different. So the cluster number 3, a lot of it is very based on machine learning models to identify, classify messages on by different categories. For example, messages toxic, non-toxic, harassing, non-harassing, bullying, non-bullying. And so researchers would train a data set based on human labeled data sets and then run those different machine learning classifiers to see how well it improves. That's why you see the word detection prominently featured there, or architecture often referred to various machine learning models. The green color cluster is more of an application of these type of techniques. And a lot of it, when we looked at sample papers from this cluster, were based on Twitter. Availability of data, of course, plays a huge role in this type of research, but also because Twitter is used to discuss public major events, and most of the profiles are public. So there's a lot of hostility and toxicity and polarization happening. So there is no shortage of data sets to analyze in this space. So you can see the discourse, keyword discourse and democracy suggests that it's a lot of hate speech. A lot of these studies are based on understanding hate speech online, in the online discourse around political movements or revolutions. There's also a number of papers on Me Too, feminism, nationalism, and another sensitive and in other cases polarizing topics. So it's more kind of application of what methods we see in cluster number 3. And so so essentially that's why grouping them together, these are the studies that look at observed data. And it's often used when it's not possible to collect information directly from participants for various reasons, if it's anonymous environment or hard to reach groups, or when it's not desirable to rely on individuals' reporting of antisocial behavior. If you ask a troll, are you trolling on why, they may tell you, why they're doing it, may not. But of course, even with this type of data, there are some limitations. We have to keep in mind things like we don't know how social media posts are necessarily perceived by those who read them. We don't know what was the intention of people who post those messages. And so we have to be kind of constantly be aware of limitations of our data sets, because this will tell us what type of research questions we can actually answer with the given data. The other point I want to make, when we are studying observed data, and that's again the topic of today's session, we need to define what we observe and what we count in. And in the literature, different authors count different things. In some cases, as you can see on this slide, some operationalize hate speech. In other publications, they look at impoliteness. In other papers, yet we're looking at rudeness or incivility, offense in comments or stereotyping. So we really have to be clear what we're counting, how we operationalizing it, so that later on we don't compare our work with something else. And the reviewer too will say, you're comparing apples and oranges. When we look at cluster 2 and 3, we also noticed 3 main approaches to analyze discourse, online discourse in this space. Manual content analysis, still very popular. It does allow us to, understand, or the readers, people who read content and evaluate it. It's easier for them to understand the context, to understand the history of the discussions, to look at the sarcastic messages better, but limited human ability to evaluate messages are limited. We can't make somebody read millions of these messages. And so that may limit us in terms of how large data sets we can analyze. So that brings us to automated analysis, and that's usually done based on the literature, based on the dictionary-based approach. When you have a set of keywords that identify certain type of behavior, certain type of attacks. A swear word dictionary is one of the more highly used dictionaries to identify profane messages, kind of lightweight signal, easy signal to detect this type of behavior for the purposes of studying it further. Of course, sometimes profanity is used as part of somebody else's group's discourse, just for fun, entertainment. Could be a norm for a group, so it doesn't necessarily mean it means messages with profane language will be insulting. So we have to keep that in mind. And so finally, it's kind of more advanced models use machine learning models that reportedly perform a bit better, reduce false positive results. For example, when some messages categorized by a more dictionary-based approach as toxic, but may not be. And so machine learning approaches are able to improve this process, but the quality really depends on what models, what data sets they were trained on. So if we have data sets that were trained on discussions about US election, and now we're analyzing discussions about Russia's war in Ukraine, it may not translate very well, even if both discussions use English as a primary form of communication. So let's keep all this kind of advantages, disadvantages of different approaches in mind. But today we are focusing on machine learning approach because it is dominant one, and it's emerging as an easy way to scale up our research on antisocial behavior, especially for communities and groups with thousands and millions of messages, where we're trying to understand trends at scale, at a larger scale. But don't worry, this tutorial is not designed for computer scientists. We actually in the social media lab are developing tools and techniques specifically for social scientists. Essentially, we imagine the audience who like the data, immersed in computational social science work, but don't necessarily have resources or desire to understand the latest programming languages or machine learning libraries. So we're building the different tools and interfaces that provides that kind of framework for us who are working in social science and humanities to still take advantage of those computational techniques and apply to our research and to our research questions. So in this sense, in this case, we're using the toxicity analysis developed by Google Perspective API team. And it uses machine learning model, specifically convolution neural networks, or CNN, which was trained on various data sets coming from social media where interactions happen and where this debate happens and where toxic interactions appear often. And when we say training data set, it means there were thousands of messages at first categorized by human beings, by multiple quarters, to say, hey, is this message toxic? Is this insulting? And so on. And then that information was fed into the CNN model, the neural network model to train it so that when you offer that model new examples from your data set, it can say with what likelihood that message would be perceived by somebody as toxic or would be perceived by someone as insulting. And so the Perspective API, so it's now part of Google, and it's part of their Google Cloud infrastructure. It's free with certain limitations in terms of how many messages you can analyze per second, and you can increase that threshold as a researcher by applying requesting a logic order. But so the reason we like using Perspective API, well, because it is considered to be state of the art, because of Google's resources available to them, and because they know the researchers like us using it, they constantly improving the models. They add in new languages, so there is that support to this kind of machine learning Perspective API approach, and there's a good documentation. So let's look at these 6 main models that Perspective API allows us to use when analyzing data sets from social media, and then we'll show you how you can actually apply it to your own data sets. So the first generic model they have is toxicity, and that's one that's been evaluated by most number of researchers and look at trying to kind of improve unconscious or different biases in the models. So the early versions you might have heard about Perspective API have been criticized for producing false positive results, especially when a certain race or sexual orientation was mentioned in posts. They would like it to produce more negative results, more toxic results than the message was. So those biases largely been improved, removed essentially, not improved, removed from the model. So it's much better now in terms of not producing false positive results in those cases. So definition would be of toxic message would be rude, disrespectful, or unreasonable post. And here's an example. This is one of the stupidest things I've read, but F me, I laughed at the second line. So there is some profanity. It's kind of toxic, but it doesn't insult anyone specifically. It could be actually viewed as sarcastic. Then you have the next level category, severe toxicity. This model is a bit more conservative, and it's trying to kind of remove this sarcastic messages that may use profane language, but not in a way to insult someone or attack someone. So it's defined as very hateful, aggressive, disrespectful post. And example could be F off, pathetic loser, comma, no one cares about your worthless opinion. So it's really attacking somebody using profane, strong language. But then separate from, but kind of subset of messages, toxic messages, we can recognize as insulting. This is where people name call or refer to specific individuals or groups in the messages usually. Example could be how F stupid is, and then somebody's name. That is pretty F stupid, period. What's next, dash? A deep fake having him say racist things as a, in quotes, social experiment, question mark. So you can kind of feel that it is very toxic, and it's also very direct towards a particular individual in this case. Identity attack, it's an example of insulting, but where essentially negative post attacking someone because of their identity, including race, gender, sexual orientation, ideology, religion, nationality, or other characteristics. Example, you people are a bunch of fags, period, and I voted for a name of a political party. So you can see it's attacking a group of individuals based on their identity. And then profanity model, or profane messages, it's very similar to the toxicity, but it's a bit more straightforward. So essentially any post with swear words or other obscene language signs would be classified in this model. And then threats. In our experience, the messages that kind of have, or based on the language used, appear to have an intention to inflict pain, injury or violence against an individual group would be classified under threat. So example could be here, shoot all yellow vests, exclamation mark. We have to kill all Nazis, exclamation marks. So the use of word kill and shoot triggered the likelihood for that messages under this model to be high as threat. Very few messages would be classified as such, and I hope your data set will not have it, because it means somebody might be threatening physical violence. So those are quite dangerous messages as well. So the model is there, but in our experience, most of the time is either misclassifying sarcastic messages, or there are very few messages of that nature. So from the practical perspective, we try all these models, and of course, I will invite you to test them yourselves with your dataset. But the most generic toxicity model, the first one, actually works pretty well to catch all kinds of toxic interactions. And then, of course, you have to kind of unpack. Once you detect the toxicity, you have to kind of examine some of the messages to understand the context, the nature, and so on. Also to note, there's a high correlation between these metrics. And this is based on one of the data sets we've examined, about 20,000 Reddit posts from kind of right-leaning group, conservative group Meta Canada. It's no longer active, but when it was, it has a lot of polarizing discussions, mostly coming from the right side of the political spectrum. So you would expect to have higher percentage of toxic interactions, and we did. But what we found here, that toxicity and severe toxicity had a very high correlation. There's certainly more toxic messages than severe toxicity because it's a subset of one. But in terms of correlation, there's a very strong overlap. Same with insulting messages, same with profanity. The only unique group we've noticed, identity attack. It's a very distinct group. So if you were to choose what metrics to use, you probably want to go with toxicity and severe toxicity maybe on one side, and then identity attack on the other side. And threats are different as well. You can see it's the least correlated metrics with other ones in this set. But again, they're very messages that were classified threats. Most of the time, also, when you look at the distribution of messages, like how many messages were classified more like more toxic than less toxic, you'll see distribution charts like these ones. So here, again, for the same Reddit group that we've analyzed, you have the distribution mostly skewed towards the left, because most of the messages in your data set will be not toxic. So it will be, that's why you have the spike close to 0. So it's the messages that on the right side at the end, close to 1, that you're most concerned about examining. And then there's that question about threshold. Running machine learning models in this case will evaluate each message, and it will assign a score from 0 to 1. And 1 is more likely to be toxic, 0 is less likely to be toxic. But what if the message got score 0.6 out of 1? Or 0.7 out of 1. What's the threshold? I mean, the developers don't recommend to use a hard kind of threshold. It also will change based on the nature of your data set or the purpose of your research. If you're trying to capture as many toxic messages as possible in your data set, setting a threshold 0.7 we found to be useful. For example, with this threshold in our data set from Reddit, about 15% of messages were considered to be toxic and 6% was severe toxic, which was high relatively to other online groups where we didn't see such a high level of polarization. So it's all relative. So with this type of research, we found it's always good to have 2 examples or more where you can actually compare and contrast things. But of course, as you lower the threshold, in this case, let's say 0.7, it also means you might be introducing more false positive results. So examples where a message might not be toxic, but it was perceived toxic by software. And so in those cases, you can try to increase this threshold to 0.8, 0.9 is the most highest score. Threshold, probably you want to go as high as 0.9, which means you find fewer messages classified as toxic, but those that were classified more likely to. So in this case, for this data set, we reduced from 15% of toxic to examine on only 5%, especially if you have a human element, human core element here, and you want the humans to examine in details more toxic messages that are most likely to be toxic, then setting threshold higher, 0.9 like this, definitely makes sense. But it may be too conservative for metrics like severe toxicity, as you can see here. When we set to 0.9 for this data set, only 54 messages came up as severe toxicity. So you have to kind of, balance between your research questions, between and the thresholds here. In some other analysis, you might not need to set a threshold. So if you use toxicity as your dependent variable, for example, with different other metrics, for regression analysis, linear regression analysis, you want to have a continuous variable anyway. So that could be fine to keep it as a scale without binarizing it, essentially without dividing it in two. When you look at the documentation for prospective API, how do you interpret 0.7 score? Essentially, it says that it's not necessarily the toxicity of the message, it's how it's perceived. So it says 7 out of 10 people. So if a message got score 0.7 out of 1, it means 7 out of 10 people would likely perceive this message as toxic. If it's 0.9, it means you require 9 out of 10 people perceive it as toxic. So hopefully this will kind of help you figure out in terms of how to interpret the scores. But now let's talk about how do you get those scores to actually study your data sets. If you have resources and skills, there are a number of programming scripts, libraries like in Python and R that can interact with Google APIs, various APIs, including Prospective API. But if you don't want to worry about the coding, we have the web interface developed for this exact purpose. The program called Computational, and so we have EDU version, which is great for small projects, getting started, getting to know projects. And if you have data sets with millions of records, we have a pro version which resides on dedicated server, which is a bit more power and processing. But today we're going to use EDU version. And so as you listen into this workshop, I do invite you to register with the EDU account first. And when the workshop hands-on part will come in soon, if we have time, I will share a data set with you so that you can actually try looking at some of these networks through the community account actually and Prospective API. And so this actually brings us into the transition to Alyssa, where she will take what I presented to you, essentially the toxicity analysis using Prospective API, which only looks at individual messages, right? And classifies messages, assigns likelihood whether a message is being perceived as toxic or not. But now Alyssa will take that type of data to the next level that will help us to answer research questions at the group level dynamics. Essentially saying, what are the trends? Who are the actors behind those toxic messages? Do we see somebody being attacked or somebody getting, sending those type of messages? And this is where we see the research gap, the intersection between and interactions between toxicity analysis and network analysis. And so with this, I'm going to invite Alyssa to share her screen and introduce the concept of signed networks, which will kind of help us to combine toxicity analysis and network analysis. Over to you, Alyssa.
Thank you so much, Anatoly. Can I do a quick mic check? Can everyone hear me? Good. Okay, perfect. Let me just get set up here. Okay, thank you, Anatoly, for introducing the topic. As Anatoly mentioned, I'm gonna show you guys in a bit more detail about how we can now apply some of these concepts to research that Anatoly has introduced. So I'm specifically going to be talking about signed network and signed network analysis and how you can use that in your own research to study antisocial behavior. So let's start off with an introduction to signed networks. What is a signed network? So signed networks build on basic social network analysis concepts of nodes and edges, and with a signed network, each of your edges or
Hey,
the,
Alyssa.
yes?
We can't see anything on your screen.
Oh, you can't see my screen. Thank you. Let me see if I can do that again. Thank you for letting me know. What about now?
That's
Good.
great. Thanks.
Thank you so much. Sorry about that, guys. Okay, yeah, so as I was talking about signed networks and what a signed network is. So signed networks is where the connections between users, you assign a weight or a sign to each of those connections. And that sign is going to usually indicate the nature of that interaction and whether it is positive or negative. And by adding that additional information, you're able to answer more questions that you wouldn't be able to with just a traditional communication network would allow you to do. And this is why signed networks are perfect for studying antisocial behavior. So let's look at a simple example here to just kind of demonstrate what I mean by that. So let's say we have this example here of a standard communication network. We have John, Anne, and Mary on Twitter. And when you're usually working with publicly available social media data, this is typically what you have. You just know who is talking to who. That's all you can really know. However, with the signed networks, when we add those weights to each of the edges, we're able to know a bit more about the nature of the connections and whether those interactions or connections between users are positive or negative. So now, for example, we can see here with this example with John, Anne, and Mary on Twitter, when we add those signs or weights to each of the edges, we can see more about how these different users are communicating with each other. So in this example, what we would see here is that John maybe tweeted at Anne, and that was in a positive way, but Anne tweeted at Mary, and that was in a negative way, perhaps indicating some sort of antisocial behavior. So how can we add those signs in? Where can we, get that information? So previous approaches to adding those signs and creating a sign network has really relied on having pre-existing information about the nature of the friendships, the friendship network. In our work, and as Anatoly already introduced, we propose to use toxicity scores from Google's Perspective API to help you determine whether those interactions in your network are going to be negative or toxic or not. So Anatoly has already, just to quickly recap here. So as Anatoly has introduced, we can run a toxicity analysis with Google's Perspective API, which uses machine learning to analyze text. And in this case, that's of course going to be each interaction in your network. And recall, and just a refresher here, that you're going to get a score for each edge in your network. And that score is a probability. So if you have a score of 0.55, that means that we can interpret that there is a 55% chance that a human reader would interpret or perceive that comment as toxic. That score is going to be assigned to each edge in the network. And as Anatoly mentioned, you'll have that score and you can use it as a continuous variable, but you can also select a threshold to then dichotomize whether interactions are positive or negative. And again, you're going to get those scores for each of these different attributes as Anatoly went over. So now let's go back to this example with John, Anne, and Mary now that we would have, let's say we ran our toxicity analysis, and I'm going to go over that in a second, how you can actually do that. But let's say now we have our toxicity scores for each edge in the network. And let's say that we've added the overall toxicity score. Remember, you have those different attributes, but let's say we added the overall toxicity score. Now we have these probabilities. And let's say we're using a threshold of 0.7, where we're going to label any score above 0.7 as a toxic interaction. Now, when we look at this network, we can tell a bit more about how these users are communicating with each other. So for example, it looks like in this example, Anne's tweet to Mary we would label that as toxic, which could indicate some sort of antisocial behavior on that part. So that was an example, where John, Anne, and Mary are a hypothetical example, but here's actually an example, a real life example that we took from Twitter here. So what we can see here is we have an original post from President Joe Biden, and then we have a reply to that post. And you can see here, I won't read it out, but if we're applying again that toxicity threshold of above 0.8, this reply to Joe Biden would be categorized as toxic. And just from reading the text, we can, agree that that would be certainly a toxic message to send to somebody. So that's a bit more about toxicity analysis and how we can use that to create a signed network and how that can allow us to study antisocial behavior online. Let's take a step back now, and I want to talk to you guys a bit more about how we actually run this toxicity analysis, how we get those scores, and as well, once we have those scores and we've created that signed network, what we can do with that. So the first step is obviously to collect your data, and I'm not going to go into too much detail about how to actually collect your data. We have several tutorials on the Communalytic website on how to actually go about collecting the data. But I'm going to discuss how you can actually, once you've collected your data, how you run that toxicity analysis. And to demonstrate that, I'm going to use an example of this tweet from Prime Minister Justin Trudeau about World Environment Day. I want to take a pause here. Anatoly did mention that we are hopefully going to have time for a little demo. So as Anatoly mentioned, if you would like to follow along, we're going to start the demo in a bit. I'm going to go through a bit of a preview of how you can use Communalytic to do your toxicity analysis and what you can kind of do within Communalytic. If you don't already have a Communalytic account, if you could just, if you're interested in following along, you can go ahead and create a Communalytic education account. It's pretty easy and fast. You just need a Gmail. And then as well, so we can share, and Anatoly just shared the link in the chat if you want to do that. And then as well, if you're interested in following along, hopefully we're going to have time for that. Send a DM to Anatoly on Zoom and he will actually share the data set with you. And hopefully we will have time for that demo. So go ahead and do that if you're interested. But yeah, so let's go back to this example here. So let's say we are going to we've collected some data. In this case, it's going to be from this tweet from Justin Trudeau and replies to that tweet. So again, like I said, I'm not going to go over how to actually collect the data. We have a bunch of tutorials, but once you have collected your data, this is what you're going to see here. You're going to see this. This is what you're going to see on Communalytic. Now, to run the toxicity analysis, you're going to click on that little lightning bolt icon there. And that's where you're going to go to start to run your analysis. When you click on that, you're going to get to this page here. And before you run your analysis, you are going to have to select the primary language of your data set. So there are 7 different options here, and I'm going to come back to that at the end and just for some considerations and conclude, but select the primary language of the in your data set. Another thing to note is that when you to run the toxicity analysis, so the data set that we will share for you for hopeful demonstration, that will already have the toxicity scores in it. But if you're starting from scratch, you're running your data set, you are going to need an API key from Google. Again, we do have a bunch of tutorials on our website on how to do that. And I will say, as Anatoly mentioned, these tools that we're developing here, we are developing them for social science researchers. So to just share a bit about myself, I am a social psychologist by training. I am not a computer scientist. I don't have experience with that. However, I have been able to use these methods and, get quite familiar with them. So it might seem a bit daunting, but trust me, it is designed for us social scientists. So not to worry there. Anyways, so yes, another thing about Communalytic, just to note again, is that there is a limit on the amount of characters that it will, for the toxicity analysis to run. So posts longer than 3,000 characters will not be able to be used in the toxicity analysis. So after you select your primary language, you run your toxicity analysis. You'll be able to track the progress. Again, some of the limitations of the Google's Perspective API, it does have a rate limit, so it can only process about 100 queries per 100 seconds. Because of this, larger data sets will, of course, take a bit longer to process. Okay, so that's how you run the toxicity analysis. Once it is run, it's completed. The next step is to actually visualize your network, and Communalytic is amazing. You can visualize your network and you can see a bunch of things just within the browser within Communalytic. So after you've collected your data, you run your toxicity analysis, you can click on Visualize Network. From there, you're going to generate the network. And in the case study I'm going to talk about in a bit, we did a reply to network, but the type of network that you generated, it just depends on your research question and what you're interested in studying. You'll generate your network. After that, you're going to click on Visualize Network. And once you do that, your browser is going to automatically open the network visualization. And this is what you'll see. And in this case, each node or each circle there represents a Twitter account. And the lines represent connections between nodes. And in this case, because we're studying a reply to network, the connections between nodes represent who has replied to who. So this is what we started with. This is what it looks like on Twitter, this original tweet from Justin Trudeau. And then we have the replies to Justin Trudeau as well. Now, when you first click on that Visualize Network, this is what we showed here is a bit after you do some steps to make it easier to visualize, but this is what you're going to get at first. So when you first open up the network visualization, it's kind of just going to be a clump of nodes, and there's going to be a lot of visual clutter. It's a bit difficult to see what's going on here. The great thing about Communalytic is that there is a lot of things built in that make it super easy to help you see what's going on better. So one of the things that we have here in the control panel is the network layout option. And what this does is essentially applies what we call a layout algorithm to your network. And this makes the network a lot easier to visualize. How it does that, and the general idea behind layout algorithms, is that it helps to display nodes in your network on the screen in a way that minimizes the number of overlapping connections, and just like I said, overall helps to reduce visual clutter. And like I said, the great thing about Communalytic, it's really easy to do that, with just a click of a button. So let's say we did that, we clicked that button, and you can see, since this is a relatively small network, you're not going to need to run that network layout very many times for it to just be more readable. So now you can see, going from this clump of nodes to this, it's a lot easier to see what's going on here. We have Justin Trudeau and his original tweet in the middle. In the inner periphery right here, this core here, we have users who replied directly to him. And then on the outside, we have users who then replied to those replies. Another thing that is really great about Communalytic is it makes it really easy to investigate specific users or specific nodes in your network very easily. So as you can see here, you can select different nodes of interest. So the reason that this node here was of interest to us, the one that is circled in red there, it seems like there's a lot of connections surrounding that node. So what you can do is you can select that node, and what you will see there is this will open this panel on the side. And with that, it will be really easy to see the different interactions that that user is involved with. So first you can see the tweets that that user is sending, so tweets from that user. And then you can also see tweets that were being sent to that user. So Comutalytic makes it really easy to see this. Another thing that you can do is you can filter out different edges in your network. So one thing you can do that's really helpful is you can actually filter out edges or connections in your network based on their toxicity score. So you'll see this option on the control panel on the bottom right-hand side. You'll see that it says min toxicity there. And you can use that sliding bar to essentially select your toxicity threshold and then filter out any edges that do not meet that threshold. And one thing to note is, as we've mentioned, when you run the toxicity analysis with Perspective API, remember it gives you, that overall toxicity score as well as the different attributes. In Comutalytic, this is based on the overall general toxicity score, so that's just something to keep in mind. But yes, you can very easily, just with a simple slider, apply a toxicity filter here. And what you can see is once you do that, in this particular example, several of the edges, you can see that the network looks like it's missing a few different connections. In this example, you can see that when we applied that threshold of 0.7, meaning that any edge or connection that didn't meet that threshold for toxicity was filtered out, it disappeared. Because so many have disappeared, what we can kind of say here is that it doesn't seem like there's too much toxicity in that network. It means that it looks like many of our edges were not actually classified as toxic. Okay, and then again, going back to that, remember we had kind of already hypothesized that user, they were receiving a lot of edges. After applying our toxicity filter, we can go back to that specific node, and what we can see is that that user now, you can see even in the control panel here, any of the tweets that they were sending have disappeared because they weren't toxic. What we can see here is it seems that this user was actually on the receiving end of the toxicity, that they, we could see that they were actually tweeting in support of Prime Minister Justin Trudeau. So that put them as a target of toxicity. So we have about, I'm just going to take a bit of a pause here. We have about 15 minutes here. So we're running out of time. So I am going to go ahead and just move on to the last bit of my presentation to hopefully have enough time for some questions as well. But as I mentioned, the Comutalytic, we have a ton of tutorials. So at first we weren't able to do the demo, but go to the Comutalytic website, which we'll share in the chat, and there's a ton of tutorials that you guys can use to go through these things yourself. Okay, so that was Comutalytic. Comutalytic is great. Like I said, we've designed this for social scientists to make it very easy for social scientists like myself, like many of you, to study antisocial behavior online. I'm going to quickly go through a case study here that we ran actually by exporting, or we collected our data on Comutalytic, we ran the toxicity analysis, and then we exported the network, and we actually imported that into a third-party social network analysis program called Gephi. And I'm going to go through this quickly again, just to make sure that we have time for questions. But the main thing that I want to highlight here is that Gephi can certainly allow you to do a few more things than you can do in the built-in visualizer on Comutalytic. However, many of the things that you can do in Gephi, with several different clicks in Communalytic, it's a lot easier and more user-friendly. So I'll point out some of these things as I go along here quickly. Okay, so this was a case study that we ran a couple years ago now during the pandemic. We collected public replies to 2 COVID-19 related tweets from 2 different American political leaders. So these tweets are from fall 2020. That's when we ran this case study, and we selected these 2 tweets. One tweet was from Donald Trump, and to provide a bit more context here, this was the tweet that he sent out when he could tweet after he got COVID. And in this video, he's saying that getting COVID was a blessing from God. On the other hand, we had this tweet from Joe Biden, which is, the sentiment of that is almost the complete opposite, where he's highlighting the severity of the disease and criticizing the current administration. And why we were interested in studying these 2 tweets and then the replies to those tweets was because we know that there is a divide between supporters of both of these leaders, of course. And over the pandemic, that divide had only really deepened. And what we kind of see here on both sides of the aisle is that each side thinks that the other side is so different from them. They think that there's no similarities, and there's definitely a lot of hostility being exchanged across the aisles. So we were interested to see then, with this expected divide, when we look at the networks and specifically toxicity in both of the networks surrounding both of these tweets, do we see that difference reflected? Do we see that difference that one side thinks they're completely different? Do we actually see that difference reflected here? So that's what we did. We used Communalytic, we collected the data, and we ran our toxicity analysis. And like I said, we exported that to Gephi. Just like in Communalytic, when you originally export your data, it is just going to kind of be a clump of nodes. So you certainly have to apply that layout algorithm to make visualizing your network easier. As I mentioned, here's one of the things where in Communalytic, it's a lot easier to do. It's, just a click of the button. In Gephi, you do have to do it manually, but there are several different options that you can choose from when you are doing this. So 2 that we like to try out first, there's Force Atlas 2. That's one of the ones that we like to try out first, and Frucherman Rheingold. However, our overall advice to you here is to just try out the different options and see which one works best for your data set and your network to reduce that visual clutter. Another thing you can do once you've now imported that into Gephi is you can change the node size to make your network a bit easier to visualize. So what we just did in this case study, and as you'll see, is we changed the node size to represent out degree centrality. So this meant that larger nodes in our network represented more active users, or those who were replying to many other users in the network and replying more frequently. The final thing that we did to make it easier for us to visualize our network and to study antisocial behavior was to change the edge color. And this is where we actually, this network, we are able to visualize toxicity. So what we did is we actually used a gradient. So I believe for this data set, our toxicity threshold was 0.7. And you can see here what we did was we had that 0.7 divide, and then we used a gradient to any scores higher than 0.7 would be represented in red, and any edges with a toxicity score less than 0.7 would be represented in green. So we did dichotomize toxicity in this analysis. And here is what we got. So here is what, after we did those different steps, we can see now toxicity visualized in both of these networks. And this makes it really easy for us to look for differences and similarities between the network. So going back to our research question, as we discussed, our why we wanted to do this, what we wanted to look at is we wanted to see if that expected divide and the differences that we expect between these two groups of supporters of each leader were different. And what we can see here, looking at both of these networks, is visually, they really don't appear to be all that different. The networks are both structurally similar. So we can see that in the center, the very, very center of both of those networks, you have the original tweeter. So either Donald Trump on the left or Joe Biden on the right. They both demonstrate a core periphery structure where, like I said, you have the main user in the center and then replies to their tweet in the inner periphery, and then replies to replies in the outer periphery. So yeah, what we could kind of conclude here is that even though supporters of each leader may think, wow, the other side is so different from us, what we can see here, at least in this case, is that these differences, we're not able to see those differences here. Another thing that you can do in Gephi, there's a feature called a tab, I should say. It's called the Data Laboratory tab or feature. And it's kind of like an Excel spreadsheet. And what you can do, this allows you to further investigate specific users in your data set. So you can, in your network visualization, identify users of interest that you want to study more, see what they're tweeting, see what their people are tweeting at them. And then you can, go from there. The Twitter handle will also be collected from Comutalytics, so you can get that, and you can go onto Twitter and investigate these users in more detail. So you can see here, I've outlined the steps, but this is one of those things, again, that I want to highlight, that in Comutalytic, there's several different steps here, but in Comutalytic, it's a lot easier to kind of pick a user and then see the different interactions that that user is involved with. So like I said, once you have your network set up like that, it's a lot easier to visualize toxicity in the overall network, and you can start to identify areas of interest. So in this particular network, and based on how we set up our network for where larger nodes, represent users that are sending more tweets, we can kind of identify some of these areas here. So you can see here's one of the areas in our network where we see a larger node, and then we see a lot of red or toxic edges coming from that user. And when we further investigated that using the Data Laboratory tab in Gephi, we can see here are some of the examples of the tweets that this user was sending. So certainly this user was sending some more toxic replies, of course. So this is one of the ways you can, when studying, using these methods to study antisocial behavior. We talked about looking at the overall network and seeing the toxicity on a network level. This is one of the ways, by zooming in and looking at specific nodes. It's one of the ways that you can study toxicity or antisocial behavior on more of an individual level. Another thing in this particular case study that we did was we could also identify what we would say are like attacks. So we can see, smaller nodes with a lot of red edges being directed at them. So, and certainly, yes, when we, went through and investigated these users in more detail, they definitely were users that were at the receiving end of toxicity. Going back to our overall research question, this case study, yes, this was another example where we saw that there were not differences between the two networks. In both networks, we did see supporters and non-supporters of both leaders being the targets of toxicity. So I did show in Comutalytic how you can use that filter option to filter out and only look at the edges or connections in your network that are above your toxicity filter. You can do that in Gephi as well. However, like I said, this is one of those things that it takes a few more steps in Gephi, but in Comutalytic, we saw that it's just a slider, so it's a bit easy. The one thing that Gephi does have, though, is that in Communalytic, it's based on that overall toxicity score is what the filter is based on. On Gephi, if you are interested in studying one of the other attributes of toxicity, let's say you're interested in studying threat, you would be able to set your filter here for one of the different attributes. So that's one of the benefits of Gephi here. Finally, I just want to finally conclude here and highlight, I had mentioned one thing with the toxicity analysis that, of course, it's only validated right now in certain languages. So if you are, this is definitely a limitation, but something you should certainly consider if you are going to be running that toxicity analysis in another language. Just be mindful that this analysis is only valid in certain languages. So that's just one thing to consider. And yeah, I'll give us that was the end of my part here. I'll give us a nice little summary so we could have some time for some questions. So Anatoly gracefully took us through a bit of a summary, a snapshot of what the state of social media, antisocial behavior research is on social media. We talked about toxicity analysis, and then, you know, a bit of how you can run that toxicity analysis, how you can apply that to different research questions. Before I open it up to questions, I want to also highlight another event that is being hosted by the Social Media Lab in collaboration with Royal Roads University and our collaborators there. We are going to be having another workshop in Victoria next month in August on studying antisocial behavior online. So if any of the things that we talked about today are of interest to you, in the chat, Anatoly will share the registration link to this. Please sign up. You can attend virtually or in person. So yeah, thank you guys very much. And now I guess we'll open it up to any questions.
Thank you, Alyssa. I think we have just 4 minutes left, but enough for a couple of questions perhaps. And we're always available online on Twitter or emails. Do contact us. I know we had to go very fast. There are lots of steps involved in this process. I feel like we overshared today, but hopefully we didn't overwhelm you too much. Maybe just enough to get your interest, and then you can try certain things and then come back to us to say, hey, Anatoly, hey, Alyssa, you know, we're stuck here, and we will be happy to help you.
Yeah, the resources that we have available online as well are definitely very useful, and I would definitely encourage you guys to check that out.
And I do want to mention I shared our slide deck with you, so there will be additional links for you to examine. So if there are no questions, we can take
I think we have a question. We do have one question here.
Oh yeah, so can this tool, Communalytic, can be used to study other research topic or just toxicity analysis? It started as a tool, as a kind of interface to toxicity analyzer, but it also has data collection features. Right now, it's limited to Twitter threads. If you do have approved access to Twitter archive, you can use Communalytic as an interface to collect your historical tweets. It's also started as a tool to investigate communities on Reddit, public groups. So there's a feature to collect live or historical Reddit conversations, group specific. If you have access to CrowdTangle from Meta, which allows you to access Facebook or Instagram, you can use a API key from CrowdTangle to collect relevant posts. So the data collection component is there. We will be adding a Telegram API, working on it in August. Hopefully in the fall, we'll have big announcement for that. In terms of the analysis, there's a sentiment analysis module. Sentiment analysis can be tricky. Generally, it's lots of false positive results, but for some type of research, it's appropriate. So there is more module there. And you know what? You don't have to use toxicity scores to build and discover networks and conduct social network analysis. So what Alyssa showed you, the way to visualize networks, the way to export them, you don't have to have those weights, the toxicity scores weights. So any topic can be visualized as a network, as long as it's appropriate for your research questions.
We have another question here. I can take the second question
Yeah, go
here
ahead,
about can you use some of the a more detailed type of toxicity network? So I do believe that Perspective API, one of the beta attributes that they are testing out right now is one related. So you mentioned sexist, misogyny, things like that. I believe they are testing out one of the attributes of sexual harassment. So that is one that they're still developing. You can, if you have access to that, you can get that score as well. And that would be something that you would have to take to an external program, such as Gephi, if you want to create a network based on that.
And there's another interesting question that Yana asked, very provocative. I would love to hear others people's opinion on it. So whether detecting such antisocial behavior, the way we present it, would lead to decrease of such behavior, and is it even desirable? And how can this research help to develop some solutions in this space? So as we presented it, the first step was to understand the prevalence and actors behind propagation and creation of such content. We're far away from the recommending specific policies. I showed you platforms applying different standards, community standards, and different tools to block users, to shadow ban them, to reduce the content. We know that stage to recommend, and I think for different communities, different platform solution may be different. For some groups, toxicity is a norm. It's a form to communicate. So for those groups, it's not the desirable to reduce it. It's the more extreme cases where they target, where toxicity is used to target individuals, to silence groups or individuals, and that's problematic. And for us as researchers, the first step will be to understand the scale of that problem. But the network analysis, especially the way Alyssa presented it, will allow us to detect, for example, coordinated online harassment campaigns, because you can quickly see in the network if an individual being attacked by multiple individuals within a short period of time. So that could be a signal to investigate further. There are many of one-off, toxic interactions between one user and another. So those could be problematic, but maybe not as problematic when you have kind of bunch of accounts attacking a single account and doing it systematically and in a coordinated way. And so networks can identify that. So yeah, I do hope you can join us for the workshop in Victoria BC online or in person, where we can continue these discussions. And that open-ended question that Yana, I hope I pronounce Grushina, your name correctly, you posed, that's type of questions we want to discuss further in this more designated forum. Thank you. Yeah, I think we have to wrap it up before the lightning talks around. But yes, so wonderful to see everyone here. And let's continue day 2 of the Social Media and Society Conference. See you after a quick break.
Yes. Thanks, guys. Bye.